All right, this is Anatomy Physiology Lesson 5.02, Categories of Bones and Anatomy of a Long Bone. We're going to do 2 pages on this lesson because they're kind of short. And you'll notice that I've already written quite a few things down here. So let me just read off the list and then you can pause the video and catch up your notes. But I thought instead of you guys following along with me while I write, I'll just pre-write all of these. So we have phalanges, humerus, radius, ulna, metacarpals, metatarsals, femur, tibia, fibula, clavicle, carpals, tarsals, sternum, ribs, pelvis, scapula, skull bones, vertebra, sacrum, coccyx, skull bones, and patella. So hopefully my reading is legible. Go ahead, pause the video, and catch up your notes now. All right, welcome back. We are looking at today. So when we talk about bones, we can talk about them with different describers. One of them is their shape, which is what we're doing here. So we're categorizing long bones by shape. The other ways we can talk about them is where they are in the body. So we have the central part of the skeleton and the outer part of the skeleton. But we have 5 categories. The first category that has by far the largest number of bones are called long bones. So this is an example of a long bone. In fact, this is the femur. And a long bone has kind of the classical shape that you think of when you think of a bone. You first probably started seeing bones when you were a kid watching cartoons and you'd see a dog carrying around a bone. The bone always had 2 kind of rounded ends and a long center shaft. That's characteristic of a long bone, and most of the bones in the body are long bones. But not all bones are long bones. The next group, category B, are called short bones. And these are our carpals and our tarsals, which, if you remember your med terms, are our wrists and our ankles. And they all have this kind of characteristic cube shape to them. So they're cuboidal often. And the reason that we get that cube shape is our wrists and our ankles have to support an awful lot of force. There's a lot of weight that operates on our wrists and our ankles. And this is a very stable structure. So it's great to have bones that are shaped like this, unless you break one. It can be really difficult for a short bone to heal because of this block shape. And there are some soccer stars whose careers have ended because they broke a short bone. Very difficult to heal. I see scapula kind of went off screen here. I wrote this ahead of time. Let me rewrite that. The next category is called flat bones. These are flat bones. And it's a little bit difficult to tell that it's flat, but if you could see this, it has a little bit of a curve to it, but for the most part, it's plate-like. And this is one of the skull bones. But the bones in this category are our sternum, our ribs, our pelvis, skull bones, and our scapula. And we mentioned last time the sternum and the ribs are sites of hematopoiesis or erythropoiesis in adults. But overall, they don't have a lot of curvature, maybe a little curvature. They tend to be thinner. And those are flat bones. Next category are irregular bones. Irregular bones. And the one that you see off to the left here is one of the vertebra. They have lots of projections, lots of holes. We're going to learn those holes are called foramens. The projections are called processes. Other ones, 8 of your skull bones are irregular bones. So most of them are found in your skull. Your sacrum and your coccyx, and you've probably always called these the coccyx you think of as your tailbone. The sacrum is the bottom part of the vertebral column that connects the 2 sides of the pelvis together. And that is got an irregular shape, lots of openings. The last category are sesamoid bones. And sesamoid bones are bones that form inside of a tendon. So this is the patella or the kneecap. And when we look at the patella, it's actually kind of cemented to on our skeleton in school, the patellar tendon. And when we watch knee replacement surgery, what they have to do is they have to take that. So if this is the patellar tendon, they flip it over, and the patella, I don't have anything on my desk I can use as an ad hoc patella. The patella sits right down inside that tendon. A lot of times they'll shave it smooth so it doesn't rub against the new prosthetic, the knee replacement. All right, you might be saying, hey, Mrs. B, I don't know where any of these bones are. And another thing we're going to do in this chapter is we're going to fix that. So I'm just going to pull this document down. But in your packet, you have this handout. It has all of the bones highlighted. So we start with phalanges, metacarpals, carpals. Over here, we have the radius, the ulna, the humerus, scapula, clavicle, vertebra, ribs. You have to have all of these memorized. You're going to get diagrams on the test, and I'll point to a certain bone, and you'll have to tell me what the bone is. We'll also do this in lab where I'll lay all the bones out, and you'll have to assemble a skeleton and label everything. You'll have to put all the bones in the right place. So this page is where you're going to learn where the bones are and the names of the bones. Okay, let's move on to our second page. So I'm going to pull in anatomy of a long bone. Pause the video. All right, the second thing we're going to talk about on this video is the anatomy of a long bone. My color is in copy, yours is in black and white. But what we have on the left is living bone. So this is live bone, and this is dead bone. Well, don't all bones look like this? Every bone you've probably seen if you've picked it up in the yard or cooked the heck out of it, looks more like this. It's dry. It's hollow in the center, and the bones that we have in lab that are from our skeleton, and we have a human skeleton in lab, look like this. But we'll be bringing in some of this bone for lab to dissect. So we're going to be doing lots of little mini labs for this chapter. Bone is anything but dead. It is actually one of the more highly vascularized, which means has lots of blood, tissues that there are. Remember that bone is a connective tissue. So bone, overall, lots of blood supply. We call that highly vascularized. Highly vascularized. It also is a connective tissue. It's in the connective tissue category. And it has two divisions, compact and spongy. I'll show you before I label it. And I know your handout is in black and white, so we'll try to color code this a little bit. So on the dead bone, this is spongy bone, and this is spongy bone. It's made of little tiny arches. And if you've ever gone and seen an arch in architecture, arches are really good at supporting weight. But because it's not solid, it also takes out some of the mass from the bone. Around the outside here, where it looks like a solid line, that's compact bone. Compact bone, all of the cells run in the same direction. So they run down this way, and that provides a lot of strength from top to bottom. So let's make a compact bone. Let's do some lighter colors to the outside. And I'm going to do it on the dead bone, but you'll notice on the live bone, we have counter. Over here, though, the spongy bone is yellow. Up here, the spongy bone is red, and we'll talk about that difference. But let's do the compact bone in light green on the dead, and I'm going to do it over here. So what they've done is they've cut away. So they've done a cross section. They've cut the cross section down, down, down. They left this complete, then they did cross section here. So this area is cross section and this area is cross section to show the inside of the bone. spongy bone, let's do that in pink. Now be careful, we're going to have to label these lines. So we've got lines here. That's why I'm doing these in light colors. And we'll get into the anatomy of compact bone and spongy bone in the next lesson. All right, well, what's going on with the two colors? So this is yellow, yellow, yellow. This is red. This is red marrow, and this is yellow marrow. Red marrow. So red marrow is where we have red blood cell production. And so you don't lose, in a baby, this whole bone is going to look red. But for us, a lot of our, we have a little bit of red blood cell production left. So that's our red marrow here. Outline that in red. And yellow marrow. And I'll write it in black, but my yellow writing never shows up. So you can go ahead and color in all of this in yellow if you want to. Yellow just doesn't show up well for me. Red marrow, we're doing blood cell production. Yellow marrow is fat. This is part of your fat stores. And people who suffer from malnutrition have issues with their bones. They lose their yellow marrow. Their body will take this out and it will use it in addition to your adipose. Well, you'll notice this center looks a little bit different, and I'm going to label this next structure over here. So we have a hollow compartment. So this compartment, we have a hollow compartment called the medullary cavity. And that's used for marrow storage. So I went to a fancy restaurant in New Mexico once, and they served marrow. And they brought out, what they had done is they had taken long bones, they'd cut the ends off. I don't know what it was from, what animal it was from. They cross-sectioned them first, cut the ends off, and they just cooked the marrow in the long bone, and then you kind of scooped it out, and it was like Jello. It was awful. But they paid our friends paid a lot of money for the meal, so I ate it. I think I threw up later that night, so bleh. But I tried it. So, but that medullary cavity, they just made that into their serving plate. And that's where, and again, in adults, that's going to be full of yellow marrow. All right, on the ends, and it's a little bit difficult to see, so I'm just going to circle it. So we've got it here and here. So this is the ends of these bones. This goes into the coxal bone, and it sits. If this is your coxal bone, this comes up and sits in the coxal bone. It's called the acetabulum. This is the head of the femur. So you get a lot of rubbing going on there. Well, what we have here is cartilage. And because it's rubbing against another bone, that's called articulating. So this is called articular cartilage. And this is on both ends of the bone. And we talked about briefly the categories of cartilage. As a reminder, this is hyaline cartilage. So that's the category that it belongs to. You'll notice there's a strange kind of cutout here. What this implies is they've taken a knife and they've cut this way, this way, and this way, and they peeled back this structure. So this structure has been peeled back. And that little tiny structure, so it exists all along the outside of long bones, is called the periosteum. Periosteum. We do enough med terms that you should know that osteo is bone and peri is around. So the periosteum is something that is around the bone. And all long bones have this. This is a membrane that wraps around the bone. And it's filled with blood vessels and nerves. That's why your shin bone is really close to the surface of your skin. If you get kicked in the shin, it really hurts. Well, this periosteum, if you break blood vessels, it can bruise. If you, and then you've got the whole nerve issue. So it's good because it brings a lot of innervation and blood supply to the bone, but it also can hurt. All right, that leaves us with these lines. These are called epiphyseal lines. Epiphyseal, epiphyseal lines. The common term are growth plates. So these are commonly called growth plates, but the real term for them is epiphyseal line. And when the bone grows, it grows at these junctions, both in well, we won't get into bone growth right now. So these are open until about somewhere between the ages of 22 and 25, and then they close completely. And if an osteopath, which is a doctor that works on bones, is looking at an x-ray, he can kind of roughly tell the age of a patient based on how open these epiphyseal lines are or how close they are. Also, another issue you can have is if you have a bone break and you break here at one of these epiphyseal lines, that's a big problem because that's where the growth is occurring. If you break the bone here, the bone will keep growing. It doesn't care. You just have to heal this center section. But there was a fella who I knew who had a break at an epiphyseal line and one leg was shorter than the other because it disrupted the growth in his femur when he was younger. The last thing we have to say about anatomy of a long bone are regions. So we talk about these in terms of regions. The ends have a name and the center has a name. So we have the ends. And the center. We would call this center section the shaft of the long bone. So this area that we would probably call the shaft of the long bone is known as the diaphysis. Diaphysis. The ends are the epiphysis, Epyphys, and this is the epiphysis. So the ends are the epiphysis, the center's the diaphysis. Because this is closer to, this is the part that goes into the pelvis, we're going to call this the proximal. Remember proximal and distal? So I have the proximal epiphysis, and this is going to be my distal epiphysis. And every long bone would have this. So if you're looking at the humerus, the end that's closer would be your proximal epiphysis, the end that's further away would be your distal, and then the shaft is always going to be the diaphysis. All right, so in doing a takeaway, this is all basically this lesson we looked at the categories of long bone or categories of bones. And we took the long bone and we looked at the anatomy. By the way, I wanted to add one point. If you look at this, look at how small of a portion that compact bone is of the entire long bone. But yet, if you took by weight, that compact bone is 80% of that bone by mass. So even though there's not a lot to it, it is really heavy. And you can see if we didn't have spongy bone, why the whole bone would be quite heavy. So we've got, again, our takeaway, the 5 categories of bones, all the anatomy of the long bone, and then you'll be doing some labeling to learn where each of the bones are. All right, that's all we have for 5.02. Thanks for watching. Have a good day.